Alright, welcome to the live. Today we're going to be going through GCSE Maths Paper 3, and this is a 2022 June paper. So I'm going to do every single question in this, and we'll go through how to do the questions and exam technique as well. So let's get right into it. Question 1, here is a right angle triangle. Work out the value of x. So whenever you see right angle triangle, think Pythagoras, and this is quite a nice, simple Pythagoras question to start us off. So you have a squared plus b squared equals c squared. So c is the hypotenuse, which is this longest length here. So we do x squared plus 4 squared equals 8.5 squared. And if we rearrange this for x squared, we get x squared equals 8.5 squared minus 4 squared. And if I put that into my calculator, I get 56.25. And then that means that x is the square root of 56.25, which is going to be equal to 7.5. And that's it. Nice, easy 2 marks to start us off. All right, next question. T equals 4m squared minus 11. Thank you, F1 Wags, for liking the live. Really appreciate it. So work out the value of t when m equals 3. So nice simple substitution. Write out t equals 4. Then when you see an m, put a negative 3 squared minus 11. And this can even be worked out without a calculator, but it's important to remember you're squaring the negative part too. So that means it becomes positive. So 4 times negative 3 squared is 4 times 9 minus 11, which is equal to 36, subtract 11, which is just equal to 25. You need to show this substitution step to get the mark in the mark scheme. So that's how you do this question. Nice simple 2 marks. T is equal to 25. Make P the subject in the formula D equals 3P plus 4. So far we have D equals 3P plus 4. I want to get rid of this plus 4, so I'm going to subtract 4 from both sides. So I have D minus 4 equals 3P. I do the inverse. So now I want to separate this 3 from P. So all I have to do is the inverse of multiplication, which is division. So I'll divide through by 3. So P is equal to D minus 4, and remember it's all going to be over 3. So P equals D minus 4 over 3. And that's how you do those 2 questions. Nice easy start. Hopefully it's all okay so far. Let's move on. Rick, Selma, and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick. Tony has 6 less than Selma. In total, they have 54 counters. The number of counters Rick has to Tony is 1 to P. Work out the value of P. So a long question. Let's break it down one by one. So Rick has some counters. Let's just say Rick has X counters. This is how I like to do these types of questions. Always use algebra, okay? So I set X as my base unknown. Selma has twice as many as Rick. So Selma would have 2X, right? Tony has 6 less than Selma. So if Selma has 2X, Tony has 6 less than that. 2X minus 6. So we know that in total they have 54. So if we do x plus 2x minus 6, that is going to be equal to 54. And if I simplify this, this would be 5x minus 6 equals 54. So 5x equals 60. So I know that x is going to be equal to 12. So I know that Rick has 12 counters. Selma has twice as many, which is 24. And Tony has 6 less, which is 18. And I can check by adding these to get 54. But that's not answered the question yet. I need to find P, right? So I know that Rick to Tony is 1 to P. So Rick has 12 parts, so we can say that 1 is 12, and P is going to be equal to Tony's parts, which is 18, right? So I need to see how do I get from 1 to 12, and I'll do the same thing but going the opposite direction to go from 18 to P. So I'm just multiplying that by 12, right? So to get from 18 to P, I'm just going to divide by 12. So 18 over 12 is going to be equal to P, and that is just going to be equal to 1.5. And I can check by doing 1.5 times 12, and that indeed gives me 18 in my calculator. So that's how you do that. So then I just say P is 1.5. Does that question make sense? It's a long ratios question with a bit of algebra, but it's not a bad 5 marks there. Already started. Alright, gonna move on to question 4 now. So I remember doing this question when I sat this paper. Joe is going to buy 15 rolls of wallpaper. So I'm just going to underline the number 15 because that's kind of important. Here's some information about the cost from two shops. Chic Decor has 3 rolls for £36. Style Papers, you have a pack of 5, which is 70, and then you get 12% off. So you get a discount there. She wants to buy 15 rolls as cheaply as possible because, of course, she does. Should she buy from Chic or Style Papers? And we need to find why. So this is a really good common example type question that you get in real life. So she needs 15 rolls, okay? So let's work on Chic Decor first. So I'm just going to call that CD. So 3 is for £36. If she wants 15, well, I'm just going to multiply that by 5. 36 times 5, and that's going to give me £180. So by Chic Decor, it's going to be £180. Now, she wants 15 from both places, right? So Style Papers, it's also going to be 15. So we know 5 is going to be equal to £70. She wants 15. I'm just going to do 70 times 3, which is going to be equal to £210. But that's not it, remember? Then they also have 12% off the normal price. So if this is going to be 100%, 12% off is 100 minus 12%, which is 88%. So I need to just find 88% of 210. So I just do 210 times by 0.88 as a decimal, right? And that is going to be equal to £184 and 80 pence. So these are my two answers. So now let's answer the question, should she buy from Chic Decor or from Style Papers? Well, it's quite obvious that this is going to be the cheaper option. So then we just have to say that Chic Decor is cheaper. And let's just say why, because £180 is less than £184.80 for 15 rolls. And that's how you do this question. Hopefully that makes sense. I'm just going to stay on the screen for a few seconds and move on before I move on to question 5. All right, now we're going to do question 5. So question 5 is a frequency polygon question. So these questions kind of left field because it's not really covered too much, I feel, but it's not too bad actually. So the table gives information about lengths of some pieces of string. So we have lengths, and notice these are continuous. They are not discrete values, so they're ranges, yeah? And these are their frequencies. All right, nice. Amos draws a frequency polygon for information in the table. All right, cool. Write down 2 mistakes that Amos has made. All right, so first thing I like to do is look at the axis. Is there any mistakes on the axis? So looking at the x-axis, it's all good. But the y-axis, it's quite noticeable that you're missing 40 here. So all we've got to do is say 40 is missing from where? From the frequency scale or axis. All right, so that's how you do that. Then I look at the points. Are any of the points plotted incorrectly? So, because remember, it's continuous, right? So we'll plot them at the midpoint. So 15 is plotted correctly there between 0 and 10. Then we see 20, yep, that's correct. 50, yep, that looks nice. 30 is plotted there, 25, nice. The last one is meant to be plotted in this line, but it has been plotted here. So this is the mistake on this one. So we'll just say the last point is plotted incorrectly. And when I do these types of questions, I like to say what the correct answer would be. So I then just say should be at. And now where's it going to be? It's going to be at 45 across, right? And it's still going to be 5 up because it's going to be about there. Should be at 45, 5. And that's how you'd find the mistakes in this frequency polygon question. Just going to stay here for a second before I move on. All right, quite a long question, this one, but it's not overly difficult once you realize what exactly you need to do. So Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. So that's a lot of running for me. It takes Amy, so it's a different person, 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. So it seems initially a bit tricky, like where do I start with this question? But I always like to look at the end and see what exactly am I trying to find and kind of work backwards. So I need Amy's average speed, right? So Amy's speed, well, how do I find the speed? Well, they've given me some times and some distances. So speed is just going to be equal to distance over time. And I'll just need to plug in the values. So do I know the distance? Well, not yet. That's what I need to figure out. Kind of a hint here, total distance is the same. And the time, well, it tells me she runs 45 minutes, yeah? So that's already given there. So I just need to figure out the distance she runs to find her speed. So I'm going to focus on Jess's run now. So initially she runs for 15 minutes at a speed of 6 miles per hour. So distance is equal to speed times time. So this is going to be the first leg of the race. So the speed is 6 miles per hour. Also, what we need to do is give the answer in miles per hour. And I'm going to circle that there in big so we know we give it in the correct units. So the speed is 6 miles per hour, which is fine. The time is, I'm not going to use 15 minutes. I'm going to convert that into hours by dividing by 60. So that's going to be equal to 0.25. So 0.25, and that is going to be equal to 1.5 miles. So that's the first stretch. Now we're going to look at the second stretch of the run. Okay, so the second distance is going to be the speed, which is how fast now? 9 miles per hour, times by the time. Again, 40 minutes. Let's convert that into hours by dividing by 60. That's just 2/3 of an hour. So multiply that by 2/3, and that's going to be equal to 6 miles. So now I know that Jess runs 1.5 plus 6 miles, so the total distance is equal to 1.5 plus 6, 7.5 miles. So now I can just plot that back in here to find Amy's speed. So Amy's speed is equal to the distance, which is 7.5, divided by the time, 45 minutes, divided by 60. 45 over 60 is equal to 0.75. So if I just divide that through, I get 10 miles per hour. And that's all you have to do for that question. So not a bad question, just a bit of repetitive working, but if you know how to start, it all comes together. How does that question look so far? All right, let's move on to question 7 now. The diagram shows a rectangle STUV, TQU, and SRV are straight lines, and all measurements are in centimeters. They just have this bit of waffle at the start of every question, just to make sure they can't be faulted. So the area of trapezium QUVR is 8 centimeters squared. So which one is this QUVR? That is going to be QUVR. So I'm going to label this A as my area, yeah? Show that A is equal to 2x squared plus 20x. So all I have to do is find the area of the shaded trapezium. That's it. So how do I find this area? The formula for that area is A plus B over 2 times by the height. So if I've got like my little trapezium there, this is A, this is B, and this is the height, because A and B are going to be the parallel sides. So I know what A is, like let's say this is A, and let's say this is B. So this is going to be equal to 5 plus, well, what is B? I don't know that yet. So let's see what QU is. QU is going to be equal to, well, I know this total length is 5 plus 3x, and I'm going to subtract 2x from that. So that's just going to be 5 plus x. Okay, so this section here is 5 plus x. So 5 plus x divided by 2 times by, now what's the height? Well, the height is the same on both sides, 4x, times by 4x. So that is going to be equal to A, right? So 5 plus 5 is 10 plus x all over 2 times by 4x. Now I'm going to multiply the numerator, everything in it, by 4x. So I get 40x plus 4x squared over 2. Now I have to divide everything through by 2, so I get 20x plus 2x squared. And now if I look at this and compare it to my answer, well, it's the same. So then I can just say that therefore a is equal to 2x squared plus 20x. And that's it. Nice 3 marks in the bag. I'm going to stay on this question again for a few seconds before I move on. So this one, just seeing what we're finding and a bit of algebraic manipulation. Another way this could have been done is you find the area of the entire rectangle, subtract the area of the white trapezium, and then you'll find what A is. But both ways work. All right, moving on to question 8. An electricity company charges the same Albo Lewis. Yes, this is at Excel. This is the June 2022 paper 3. So, an electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of electricity. Work out the gradient. So, they love asking gradient graph questions in the exams. And what you want to do is make sure you draw a triangle that's big enough to get an accurate answer, and make sure your points are like on the edges of squares. So I'm going to zoom into this and try and find a nice number. So this area is looking nice because the axis on the left is a bit weird. So I'm just going to find where that is an integer. So I'm just going to like start drawing down there for that part. And then if I go across here, this is a nice point. So I'm just going to go across like that. Just draw my triangle. All right, cool. So I know that the gradient is the difference in y, so the change in y divided by the change in x, basically how steep the line is. So y goes from, what is this value? This is going to be in between 12 and 16, so that's 14. So 14 minus the second y value, which is just 4, divided by the change in x, so this is going to be 100, minus, this is going to be, that is going to be a 28, and that, when you put that in your calculator, you get roughly 0.14 to 2 decimal places rounded. So that's how you would do this question. So the answer is not going to be an integer all the time, so make sure you know how to round and just say how much you round to if the question doesn't specify. What does the gradient of the sign represent? So these are the 1 markers. I hated these 1 markers when I was doing GCSEs, but you just need to look at what exactly is on the graph and what does it show. For a graph, is always going to be the y over the x, right? Gradient, that is what it is. So here, the y bit is the cost. So I'd say the cost, and it's going to be per, because it's going to be over x. So per what? Unit, because it's the number of units used, and units of what? Electricity, per unit of electricity. It's always going to be y per x. And that's how you would do this question. All right, how's it going so far? Hopefully it's all making sense. Gonna get started on question 9 in just a second. All right, so express this ugly index thing as a power of 10. So I like to rewrite it just to make sure I understand what the question is. So 10 to 150 times by 10 to the 90. Always helps rewriting just simple algebraic questions just so you know what is happening and where the powers are, because powers tend to be a bit confusing sometimes. So I'm looking at this. What is the most obvious thing I could do? Well, I could just multiply the denominator through. So I have 10 to 360 over, so 10 to 150 times 10 to the 90. Remember, if you're multiplying numbers, you're adding the powers. So this would be 10 to the power of 240. So now I've got 10 to the 360 divided by 240. So when I'm dividing powers, I subtract. So this would be 10 to the 360 minus 240. Subtract the powers. So that's just going to be equal to the square root of 10, 360 minus 240, 120. And that's what I have so far. Now, this root can also be expressed as a power. If you just check out my last video that I posted on index laws, we know that to find a root as a power, you use a fractional indice. So this would be 10 to the 120, and what is this whole power? It's going to be to the half, right? Because if you have a fraction, the denominator shows you what root to that number. I imagine this like this is the floor and this is like the roots of this plant, this fractional plant. So now again, I'm just multiplying two indices. So remember, if you have an indice and you're raising it to another indice, you multiply the indices. So 120 times 2, well, that's just times a half, sorry, that's just 60. So this would be 10 to the 60, and that's it. Unfortunately, you cannot check this in your calculators because they purposely selected really massive numbers like 10 to the 360 that it would just return a math error on your calculator. So you need to know how to do index laws and kind of trust your answer is right. So Liam was asked to express 12 to the 50 whole squared as a power of 12. Liam wrote this, so this is his working and it's wrong. So let's explain why. So imagine you are seeing this question and think what you do and see where he messes up. So he is raising this 50 to the 2. This 2 is just slightly above the 50. And then he's doing 50 squared, which is 2,500. Well, we know that's wrong. Why? Because over here, what are we doing in this step? You multiply the powers if you're raising a power to a power. It's kind of weird like that. So here, you'd say when you have powers in and out of your bracket, you multiply them. And then just state what the correct answer is. So state what is wrong, and then just state the correct answer. So 12 to the 50 squared is going to be equal to 12, 50 times 2, which is going to be equal to 12 to the 100. And that's it. So this question just pretty much assesses all your knowledge on indices. So it's not a bad question. Just need to make sure you're being very, very careful when you're working it through. All right. I'm gonna move on to the next question, question 10. So, percentages question. Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, this is the value of the car. Work out the value of the car when she first bought it. All right. So this is in these types of questions, the answer tends to be a nice number because you buy something like if you're buying a car, it's going to be a nice number, right? It's not going to be a really obnoxious looking number. That's kind of like how we can common sense check. So let's just say the value at the start, let's just call that X, okay? So first, after year 1, we have X. And the value had decreased by 12.5%. So X is going to be equal to 100%, and we're decreasing by 12.5%. So that's going to be equal to 87.5% of X. So we just multiply this by 0.875. So the new value now is 0.875x. So after year 2, you're decreasing it by 10% each year for the next 2 years. So that's just 100%, like this is now a new 100, minus 10% equals 90%. So this is going to be 0.875x multiplied by 0.9. And then after year 3, you're doing the same thing. So you multiply by 0.9 again. So that is going to be equal to, and if I put that in my calculator, I get 0.70875x is equal to this number now, right? Because that's how much it depreciated to, 17010. Now all I got to do is divide through, so 17010 divided by 0.70875. And when I get that in my calculator, I get a nice number of 24,000 pounds. And remember when I said about the common sense checking, this makes sense as an answer, right? Because 24,000 pounds seems like a number you'd pay for a car, not something like if it just had like 172 instead of 000. So yeah, that's the answer to that. Nice percentages question there. I'm gonna stay on the screen for a second before I move on. And this is also applicable to A levels as well. Like percentages always comes up in a question, and they love depreciating values. All right, question 11. Raheem has 16 shirts, 5 pairs of jeans, and 3 jackets. What a wardrobe. Raheem chooses an outfit to wear, shirt, jeans, and jacket. Work out how many different outfits he can choose. So, well, this is a product rule for counting type question. So if he selects a shirt first, well, he has 16 shirts. Then he has 5 pairs of jeans, and then 3 pairs of jackets. You multiply that, you get to 40 Bam. Nice, easy 2 marks in the bag. There's no restrictions where if he has a shirt, he only wears a jean or only wears a jacket, he can wear one of each. So just multiply that through. And you get the answer of 240. Product rule for counting questions I've seen come up. CFC Nawid, this is the June 2022 paper at Excel. This is paper 3 for the exam on Wednesday, I believe. They love product rule for counting questions. This one is nice. It's just 2 marks, but they can be more obnoxious. All right. Thank you, CFC Nawid, for the gifter badge. All right. Let's move on to question 12. Triangle question. Edexcel loves triangles as well. So DC is 8 centimeters. That's labeled. And they're also right angle triangles, by the way. That's important to know. So we're thinking what? We're thinking Pythagoras. We're thinking SOHCAHTOA. Those are the 2 things that should come to mind. So I'm just going to make a note. Pythag and trig rules. I'm just going to call that SOHCAHTOA, yeah? So angle ADC is 45. That's labeled. ABC is 20. Work out the length of AB. So I like to label that. So AB is here. I'm just going to call that X. Give your answer to 3 sig figs. So we know that if we get a nice number, we don't want that. We want to have to round our number, all right? Welcome to everyone who's just joined. All right, so I'm going to look first and see, I want X, right? So I could use this triangle to figure out what X is, but I just have an angle. I need another side length, right? So let me find what this side length is, yeah? Let's call this Y. So let's figure out what this is. So I'm going to do that. This is 8, right? This is 90, this is 45. That means this is also going to be 45 degrees. This is now a, please, is this foundation? No, this is a higher paper, but questions like this could appear, but it would be a little simpler if it was foundation. Like you may just have 1 triangle instead of 2, young Joe. All right, so this is 45 and this is 45. That means that this is an isosceles triangle. So y would also be equal to 8. So now I've got this triangle here, my big triangle. This is 90. This is going to be 8. And this is 20. Oh, what'd you know? And I want this. This is a simple trig question, right? So I'm looking at this. I have opposite and I have hypotenuse. So that means I'm going to use sine, right? Sine, and remember I put the angle in, which is 20. That's equal to opposite, which is 8 over x. I've just labeled this x. If I rearrange, x is equal to 8 over sine 20, and that's going to be equal to, if I put that in my calculator, 23.4, so on, but this one's it to 3 sig figs, right? So I've rounded it there. It's always important. This rounding mark is a mark in itself, all right? Because you can see that this is just a simple trig question, but the 3rd mark comes from rounding it correctly. Don't lose out on simple marks just because you forget to round, all right? Underline it, circle it, star it, make it bold so you know you need to round. That's what I did in my finals, and it really helped actually. All right, vectors questions. I've heard that vectors could come up in the GCSE paper 3, so this is not too bad of a question to get. Pray you get something like this. No worries, young Joe. All right, so a and b are vectors such that a is this and 3a minus 2b is that. Work out b. With this, it's just an algebraic equation, but you've got like 2 equations, one on top of the other, yeah? So if I've got 3a minus 2b equals 8 minus 17, I'm just going to sub in my vectors, yeah? So 3 lots of a, which is what? 2 minus 3 minus 2 lots of b. Well, I need to find b, right? So I'm just going to say that b is going to be equal to x, y for now. Just put in any numbers or letters. So it could be a or b, but they're using those so x, y makes sense. So 2 lots of x, y, and that's equal to 8 minus 17. Now, like I said, with this, you're just multiplying both numbers through by the scalar. You're just scaling the vector in both directions. So 3 times 2 is 6, 3 times minus 3 is minus 9, minus 2 lots of x and 2 lots of y. That's equal to 8 minus 17. Don't mix up your negative signs. Here I've just multiplied through by 2 and the negative sign is still out there, alright? So now I've just got 2 equations, my top and my bottom equations, and I can solve them separately. So 6 minus 2x is equal to 8. If I rearrange, I get 2x is equal to negative 2, and that means that x is negative 1. There's my first thing, bam, put that in my vector. Let's look at the bottom equation. Minus 9 minus 2y equals minus 17. I'm going to rearrange again, bring the 2y on the right side, so 2y equals, and add 17 to both sides. That's going to be equal to 8. So y is equal to 4. And boom, that is my vector done. Nice vectors question. So vectors could come up. You don't know what sort of question they could give. Just make sure that you remember your rules for vectors. When you multiply by a scalar, like these 3 and the 2, you multiply everything through by that number. And if you're adding and subtracting, you do the top rows separately to the bottom. And you can always just put in like a placeholder vector by making up x and y and trying to find what those are. Then you've just got two equations to solve, and that's it. Vectors is not too bad, like once you like with a bit of practice. All right, how is this looking so far to everyone? Thank you for joining the live and staying on. Hopefully this is helpful. Let me just check if there are any comments. Nope. All right, cool. Let's move on to question 14. When I see a question like this, I get very excited because for me, I love algebra, and this is like just pure algebra, straight up. All right, what paper is this? GSS Transport. This is a June 2022 EdXL higher paper. And this is paper three, and this is in practice for the exam on Wednesday. All right, let's get into this. Factorize fully 4p squared minus 36. So first I'm going to take out the number, right? What number is the highest common factor between 4 and negative 36? No worries, GSS Transport. So 4 goes into both numbers, right? And I've just got a p squared here. I've not got any letters here, so I can't take that out. All right, cool, that's it. So how do I get from 4 to 4p squared? Well, I multiply by p squared. How do I get from 4 to negative 36? Well, I multiply by minus 9, because 4 times minus 9 is minus 36. Most people, well, some people might stop there, but read the question carefully. It says fully. This is the important thing, because what do you notice about this thing here, p squared minus 9? They love sneaking these types of things in. It's a difference of two squares. So that would be 4. And remember, I do something plus something and something minus something. Well, I just square root both the things here, right? So this would be p plus 3, p minus 3. And that's it in factorized form. So always remember, read the question carefully, see if there are any tricks, yeah? So this is kind of like a trick. And it's worth 2 marks, right? So if you just did this first line of work and that's kind of like 1 mark, you'd be like, oh, that's it for 2 marks. Always like try and suss out the question, okay? If it's 2 marks, see, have you done enough work to get those 2 marks? If not, then you might be missing something. Here is the difference of 2 squares. Always look out for that because it's something that's taught, but it comes up sneakily in the exam papers. It may not always be obvious. And they even do that through to A level. They always hide that in. All right, I'm going to stop waffling. Moving on to part B. Show that this triple set of brackets can be written in the form am cubed plus bm squared plus cm plus d, or a, b, c, and d are integers. So the only thing we can really do is expand this, right? I just see this and I'm just going to think, okay, expand it. So m plus 4, 2m minus 5, and 3m plus 1. Some people can just do it like a multiple at one go. I like to just do it a bit separately just so I don't make any silly mistakes, all right? So I'm going to expand the first set of brackets first. So m times 2m, 2m squared, m times minus 5, remember the signs, that's minus 5m. 4 times 2m is plus 8m, and 4 times minus 5 is minus 20. Again, remember the negative signs. And 3m plus 1 is just sitting there for decoration at the moment. I can simplify this so I have less terms here because common like terms between minus 5 and 8. So that's 2m squared minus 5 plus 8 is plus 3m minus 20. And again, this is just stuck onto the tail for decoration. Now I can't really simplify this further, so let's expand out by multiplying again. 2m squared times 3m is 6m cubed. Remember, m squared times m cubed. 2m squared times 1 is plus 2m squared. 3m times 3m is 9m squared, and 3m times 1 is plus 3m, and minus 20 times 3m is minus 60m, and minus 20 times 1 is minus 20. And that's it. Just take your first term and multiply by everything in the second bracket. Do it logically so you know you've multiplied everything through and you've not multiplied anything like twice in a row. Now, I'm just going to simplify this. 6m cubed is the only m cubed term. 2m squared plus 9m squared, that's going to be 11m squared. 3m minus 60m is minus 57m. And there's only one constant, minus 20. Like this minus 57 kind of looked a bit obnoxious to me. So if a number does look a bit obnoxious, don't always be put off. Because remember, this is a calculator paper. They can give you bad numbers. They're not going to give you nice numbers always. But this is what it would look like. And you can just sometimes state that A is 6, B is 11, C is negative 57, and D is negative 20. You don't need to state the last part. You can just show this is enough, but yeah. So that's how you do this algebraic question. And it's 5 marks. Like, I find this quite fun. Like, I sound like such a nerd saying that, but compared to other obnoxious stuff you could get, this is pretty nice question to, just do midway through the paper. All right, how's this looking so far? Thank you everyone who's joined the live, and welcome to my live. I'm doing the June 2022 at Excel paper 3 higher for the exam on Wednesday. All right, I'm going to move on now. If there are no questions on this, triple brackets, honestly, the triple brackets is a blessing. So I'm praying you guys get that in your exam, get those marks. Come on, guys. Okay, and that is followed with a circles question. I hated circle theorems when I was doing GCSE, but like just memorize the rules, I guess. I think there are some good simulators, like Google Circle Theorem Simulator, and like play around with it, like just see how it works, and it really helps to like get it in. I did that during A levels as well, like that's when I fully learned it. Okay, P, Q, R, and S are 4 points on a circle. Well, nah, I can see that. P, X, R, and S, X, Q are straight lines. Prove that triangle PQX and SRX are similar. So if they're similar, that means that one is just a scaled version of the other. What does that mean? All angles are the same. Because that's kind of like the only thing we could figure out. We don't know their lengths. They haven't given us any lengths, and we can't really prove relationships with like unknown lengths. That's going to be a bit weird. So we'll focus on angles. All right. So the first thing that shouts out to me is the angles in the same segment theorem, right? So this angle and this angle, if I like start off at these points and I make my two like segment triangles, these two angles are going to be the same. So then I just say angle, and I follow PQX. PQX is equal to angle SRX. SRX. And now I have to give reasons, okay? I can't just say angle equals angle. I have to say why. Well, angles in same segment are equal. I'm trying to write as fast as I can so I don't waste time. But yeah, opposite angles in the same, and then angles in the same. Exactly. So that's the next one. Nice. CFC. Now read. So the next one is opposite angles are equal. So which ones are opposites? It's going to be PXQ. So this one, I'm just going to put 2 lines there, and SXR there. These are vertically opposite angles. So I can just say PXQ equals angle SXR, and you can write angle using this little like part of a triangle notation. And why? Vertically opposite angles are equal. So it's important to say they're vertically opposite and they're equal, and here angles in the same segment and equal. These are the words that get you the marks. And I've still got one angle left. Well, we could just say that, well, because 2 of the angles are the same in each triangle, the third one has to be the same. Or we could just say, well, this and this is also angles in the same segment from these. So we can just say that angle QPX equals angle RSX, and same as reason 1. Or we could just say about 180 minus the 2 other angles. It has to be the same, yeah? So either one works, and don't write like this thing same as reason 1 in your exam. Just put the full reason. It's like it's your final paper. Don't risk it, yeah? So then I've not fully proved it yet, right? I need to therefore like state my conclusion. In a proof, always state conclusion. Okay, and this is something that sometimes people tend to forget. Even if they do all the work incorrectly, they'll forget the conclusion and won't get the last mark. The last mark will be conclusion. So, therefore, the triangles are similar. That's all you need to kind of say, but I always waffle in my exams and I write a lot. So I say, therefore, because all 3 pairs of corresponding angles are equal. Yeah, the corresponding means the angles that match from one triangle to another if we were to like kind of scale it and bam, put it there. So yeah, chunky circles theorem question. It is again also 3 marks, but it's a bit more working, you can see. But hopefully this kind of helps make it a bit clearer how to approach these questions, yeah? So first, see what sticks out to you and go for it. And then just see like I want to prove similarity, right? I've not got any side lengths, so I can't really do that. So I'm going to focus on the angles. Congruency, you do kind of a similar thing. You just see which rules can I use to prove like SAS or ASA or RHS, and then try and prove those things and just state your conclusion, yeah? Always state your conclusion to get your last mark. Bam, done. Khalas, move on. So, this question, again, kind of a little weird question, but not too bad. So, P is equal to the square root of 2E over F. E is 6.8, correct to 1 dp. F is that, to one significant figure. Work out the upper bound for P. Give your answer correct to 3 sig figs. When I see this, I am going to straight away write 3SF on the top and underline it. I did this even in my finals. Like, you'll just see scribbles all over my papers, just because I don't want to forget that, all right? So I need to find the upper bound for P. Well, what exactly is P? It helps to rewrite the question if it's just a simple algebraic equation. P is that divided by that. Well, I want the upper bound, right? So upper bound, I need the maximum number, right? So if I'm doing the square root of something over something, well, I need a big number divided by a small number, right? To get a really big number. 2 times 6.85 over 0.0. Yes, that is the correct answer. Yeah, it's all about error intervals and rounding. So you need to be good with that. So like sometimes they could just give you a nice simple 2 marker. What is the error interval? Or they could give you this where you got to apply it a bit more. So I need a big number over a small number. So, well, for E, I need the upper bound. What is the upper bound? Well, it's rounded to 6.8 to 1 decimal place. So I'm just going to see what number rounds down to 6.8. Well, that's going to be 6.85, right? Because if I kind of round, like, it's not going to be that, but it's like going to tend towards that. So if I round that down, it'll be 6.8. So that's my upper bound. F, I need the lower bound, right? Because I'm dividing by a small number to get a really, really big number. So the lower bound of this is 0.045, right? Because imagine if I round this to 1 sig fig, it's going to round to 0.05. The way you do it is you take the last place value. So I'm just going to write this here. Take last place value or equivalent for significant figure and take that as 1. Then you have it and the bounds are plus minus that. All right. So here you have 6.8, so that'd be 0.1 divided by 2 is 0.05. So that means that the bounds are 6.75 or 6.85. You see, you add and subtract that. That's how the bounds work at the end of the day, all right? So now I just got to plug that in. So that's the square root of 2 times 6.85 divided by 0.045. And that is going to be equal to 17.44 and so on. I just put dots, like I write it to one more sig fig than needed, and then I show I round, just so they can see that I've done that last step. How much am I rounding to? Oh look, I conveniently wrote it up here. 3 significant figures. So that's just 17.4 to 3 sig figs. And that's how you do a bounds question. So just kind of logic it through, right? So if you want a really big number and you're doing something divided by something, do a really big number divided by a really small number, you get your answer. All right, and the square root doesn't really affect it either way. That's just there, like kind of for decoration when you're thinking at that point. So how's this making sense so far to everyone? If there are no questions, I'll move on to question 17. All right, nice. Let's move on. So histograms question. I have mixed feelings about this topic. Bounds, yeah, that was bounds question, the previous one, yep. So histograms, kind of long, but we gotta do it. This table gives information about the distances in miles that some year 10 students live from school. Just draw a histogram. Okay, kind of straightforward if we know how to do it. There is a formula you need to remember for histograms. As soon as you see histogram, the word histogram, write out this formula. The way I did it was frequency equals FD times CW. The single word is equal to the 2 double words multiplied by each other. So frequency density times class width. All right. So I know that the frequencies are given in this table, and I know that we can figure out the class widths from these. So I'll just put CW up here. What's missing? FD, frequency density. So FD, if I just rearrange this, is equal to the frequency divided by the class width. So 90 divided by the class width, what's the width of this class? 1. 90 divided by 1, 90. 48 divided by 0.5. So this is 48 divided by 0.5. That's going to be equal to 96. Then 22 divided by 0.5, 44. 8 divided by 1, 8, nice and simple. 12 divided by 2, 6. All right, these are my frequency densities, and that means I can just plot them on this side here. So looking at my numbers, I go from 6 to 96, like that's my range, right? So I need to make sure this can all fit. So I'm just going to count 2, 4, 6, 8, 10, 12. So I've got like 12 squares. I'll go up in tens, like that makes most sense, yeah? So this would be 20, this would be 40, this would be 60, 80, 100, 120, and so on. You can also put like 110 here and all, but I'm kind of lazy, so I'm just going to leave it like that. And the distances has already been given. So the distance from 0 to 1 has a frequency density of 90. So I go up to 90 and make sure I go all the way across the bar correctly. There, and I'm going to join down to 1. Because remember, that's the class width of the first class. The next one goes from 1 to 1.5. So it's just going to go this little box here, yeah? That has a frequency density of 96. So if that's 90, they will go up in twos, right? So 2, 4, 6, that's going to be where it goes. Draw my little line and draw back down. Obviously, it goes without saying, do it with a ruler in your final. Make sure it looks all beautiful and stuff. And then next one, 1.5 to 2, I need to go 44. So that's 42, 44, 2 up, go there, and go down. Awesome. The last one, second last one, sorry, 2 to 3, that's just all the way across, and that's going to be 8. So that's going to be about there. 1 second, drew that bad. There, and go down. And the last one is from 3 to 5, so all the way across. That has a frequency density of 6. So that's just going to be right underneath. Nice. And down. And there's my histogram drawn. 3 marks. Make sure you know how to draw and understand histograms. And remember the equation. As soon as you see this word, write that equation, because it will help. Trust me. I feel you will have to use it at some point in a histogram question. Okay, cool. Part B, I see another histogram. This is information this time on year 11 students, which most of you guys probably are in. Frequency densities are given there, and I haven't been given a labeled axis, which is delightful. The number of year 11 students who live between 1 and 2 miles from school is n. Find an expression in terms of n for the number of year 11 students who live between 3 and 5 miles. So this one, you got to kind of use algebraic relationships and just label the hell out of this graph, okay? So between 1 and 2, that's this box. That has a frequency of n. Number of the who live there. That has a frequency of n, okay? So what would my frequency density be, right? Histogram question, write the formula. FD equals frequency divided by CW. Well, the frequency is going to be equal to 9, right? The class width is just 1. So the frequency density is also just n, okay? So frequency density is n. I need to find the frequency of this section here. So the frequency is the frequency density times class width. So frequency equals FD times CW. And this is a bit of an exam advice. If you don't know how to figure out, let's say, the frequency density, but you know this is what you have to do, just write it down. Write down the formula. You may get some method marks for that, who knows? And then make sure the examiner, you know what you're doing, right? So they can trust you a bit more, right? So I don't know the frequency density yet, but the class width is 2. And the frequency is going to be equal to what I want to find, right? So the frequency density, how am I going to figure that out? Well, if that's n, this is going to be 2/3 n, and this is going to be 1/3 n, right? Because n is 3 boxes up. So let's say that I've got here 3 boxes, right? And all the way across, that is 15 boxes, right? That's equal to n. So I know that this frequency density, FD, is going to be 3/15 of n, right? Because that's just this height. So that's going to be equal to 3/15 n times 2. And I'm fine having my n there. Why? Because the question says in terms of n. So 3/15 n times 2 is going to be equal to 0.4 n as a decimal. So that is what your answer would be, 0.4 n. So this one, what's the weird bit about it? Like finding the n relationships, yeah? So you know that like this is how we're overarching seeing it. So this is 1/3, 2/3 n. All right, cool. That's not in any of those, but that's 3 boxes. N is 15 boxes. So this would be 3/15ths of n, right? So just counting the number of squares, and you can just see how we got n as our first frequency density. How is this looking so far, guys? Thank you to everyone who's joined again. So yeah, that was a histogram question. Again, I still have mixed feelings about them. Yeah, I don't like them. All right, question 18. Here is a prism ABCD SPQR. All right, nice. The base ABCD is a prism of a square of side 14 centimeters. It's important to note that it is a square. Just on my pen, yep. It's a square, right? Which means all the side lengths are going to be the same. That might be a bit of a help for the question because sometimes people forget to note that you are looking at a square and the side is already given. T is a point on BC such that the ratio of BT to TC is 4:3. Okay, as soon as I see this, I label the side. So this is BTC, right? So this is 4 parts out of how many parts? 7. Remember, 4 plus 3 is 7. And this would be 3/7. All right, cool. So I've used that fact. The cross section of the prism is the shape of a trapezium of area 147 centimeters squared. CR has a length of 12. Well, they've leveled that, so cool. Find the size of the angle between the line ST and the base ABCD. Okay, well, this is my base. I'm going to do my little angle there and imagine it touches the floor. And I'm just going to put another line there to join them. So yeah, what do I notice? Whoa, I've got a triangle, guys. So I'm going to do a bit of geometry with angles and lines and stuff. So what you have to do is just use the facts you've been given, okay? So it's telling me that the cross section, that's if you look at it from the front and like you imagine slicing through. So that's going to be this shape here, okay? So that has an area of 147 centimeters squared. So I'm just going to draw that out for you guys here. That is going to be A, P, Q, and B. I've been told that this QB is 12, right? Because it's parallel to RC, which is given. And I know that that's 14. Okay, if I'm looking at this triangle, I want to find out some lengths for that to solve for an angle, right? It's a right angle triangle right there. So let's try and figure out what the length SD is. SD is equal to PA. So let's call that X. I know one fact. What is that fact? The area is 147. So I'm going to use my area of a trapezium thing again. So that's going to be area equals the parallel sides added, x plus 12. I find the average by how? What? Dividing by 2. Multiplied by the height, which is 14. That's going to be equal to what? 147. I know that. That's been told to me. So that means I now just do 147 divided by 14. So we get x plus 12 over 2 equals 21 over 2. And if I multiply through by 2's, they go away. So x is just going to be equal to 21 minus 12, which is going to be equal to 9. Boom, done. So I know that this bit here is 9. What else do I do? Like, could I find ST? Could I find DT? Let's think. I haven't used one of my facts yet. So I've used all these facts so far. The fact that 14 was there and that's the area. This bit I haven't yet used. That's another bit of exam advice I have. If you haven't used any of the stated facts and you're struggling to find what the next step is, see how you can use that, okay? So this is kind of prompting me, okay, I'm gonna look back here and try and figure out what DT is by looking at this little triangle back there, all right? So if I just draw that out, and it always helps to just draw those shapes in your exam. So I label the size DCT. Cool, that's my right angle. I know that the back is 14. Why? Because it's a square, remember that's important. This bit is 3/7 of the whole thing. Well, what is 3/7 of 14? Well, we can do that in our heads. That cross cancels to 2. That's just 6. Awesome, 6. What do I want to find? I want to find this side, right? So let's label that y. What do I know? I've just got some nice Pythagoras. So y squared is 14 squared plus 6 squared. So y is the square root of 14 squared plus 6 squared. And don't round yet, okay? So they want the answer to 1 decimal place. Whenever you're doing the workings, don't round there. I cannot stress that enough, all right? Keep it in exact form or to as many decimal places as you can. Store that answer in your calculator so you use the full answer. So here, this would be 2 root 58 in exact form. Not done yet. Why? I need to find the angle here. Let's call that angle theta because, you know, we're fancy like that. Gonna draw another right angle triangle. This is my last one, I promise you. So that is theta. This is T, D, and S. I know that this is going to be 9, and I know that this now is y, right? This was y. What is y? 2 root 58. Don't be put off that you have a surd, okay? It's not bad to have a surd in this. Because keep in mind, question 18, we're almost at the almost at the end of the paper. Yep. So what do I do here in this stage? I'm just going to use trig again. So this is opposite. This is adjacent. Adjacent is just next to, right? So I'm going to use tan of theta equals opposite 9 over 2 root 58. So that means that theta is inverse tan. Tan to the minus 1 of 9 over 2 root 58. And what is that going to be equal to? 30.57 dot dot dot. Remember, I like showing that I've rounded, show that I've done that step. That's equal to 30.6 degrees to 1 decimal place, which is what they said. 30.6. Nice. So this was a 5-marker question. Initially, it looks quite ugly. I'm looking at the screen now again with all my annotations. It looks ugly still. But if you break it up and see what the different parts are, it's not too bad. It's just using a bit of problem solving. Use the facts they've given you and just work your way through it. Let me just check the chats if there are any questions. How are we all going so far? Is this looking good? It's kind of helping you guys? Let me know anything in the chat if needed. All right. Just stay on the screen just for a few more seconds in case anyone wants to finish looking at that. Before we move on to the next question, in this question there's a few more questions left in the paper. All right, I'm going to move on to question 19 now. So this, if I got this, I said I love pure algebra. If I got this towards the end of the paper and it's 4 marks, I would be so happy. So show that 3x over x plus 2 minus this thing minus 1 can be written like this. Well, what's the only thing I can do? We'll just try and do the math, right? Do the subtractions here. So again, rewrite out the algebraic equation so I know I've understood it. Plus 2 minus 2x plus 1 over x minus 2 minus 1. It helps to do this, so it can also help you spot if there's anything else you need to do, yeah? So what do I do when I'm subtracting fractions? Well, I need to make sure they all have a common denominator. Well, they could have x plus 2 times x minus 2. That's just 1, right? So I'm going to do a big line now and put them all over one fraction because I can, right? Because you can. So 3x, what do I do to get from that denominator to this? Well, I'm multiplying by x minus 2. So I do the same to the numerator and denominator. So I'm not changing the fraction, right? It's equivalent. Minus 2x plus 1. What am I doing to multiply x minus 2 to get this? Well, I'm multiplying it by, by x plus 2. So x plus 2, remember to put the whole thing in your brackets, yeah? Because you're multiplying the entire things through by that. Minus, well, 1 is being multiplied by everything. So that's x plus 2, x minus 2. All right, and now I just have to do quite a lot of expanding, but it's not too bad. All right, so 3x squared minus 6x minus, and I'm going to focus on just expanding the brackets first, yeah? So that's going to be 2x squared plus 4x plus x, so that's plus 5x plus 2 minus, again, just focus on the brackets. This is a nice difference of 2 squares, so x squared minus 2x plus 2x, they cancel out, right? Minus 4. And that is going to be all over what? X squared minus 4 again. And hey, I'm looking at this denominator here, and I'm looking at this. I'm on the right lines. It's looking good so far, yeah? Now we're going to expand out by multiplying through by a negative. Negative means swap the sign. So 3x squared minus 6x. Just swap the signs. So 2x squared was positive. It's going to be negative now, right? Minus 2x squared. Swap that. Minus 5x minus 2. Swap these. Minus x squared. Now this was negative. That's going to become positive, right? So that's plus 4 all over x squared minus 4. Now all I have to do is add and subtract and I'm home free. And I'm looking at my answer, it doesn't have an x squared term. So I gotta hope the x squareds go away. So 3x squared minus 2x squared minus x squared, thank God. That's gone. I don't want that. Get out of here. All right. Now I've got minus 6x minus 5x. That's going to be minus 11x. Do not be put off by the fact you have a minus. You're at the end of the paper. You can get weird numbers. Now looking at my constants, minus 2 plus 4 is plus 2. Over what's my denominator? X squared minus 4. Is that in the form they wanted? Something x plus something? Yeah. And don't be put off if that was -2. It would be plus -2, yeah? So a and b are integers, and that is your answer. Really nice question actually to get towards the end of the paper. It's kind of a bit of a relaxing thing compared to, critically thinking with all those shapes. But yeah, how is this looking so far? I'll stay on this for a few seconds before I move on to the next question. All right, let's move on to question 20. So, the profit made by a shop increases each year. You'd hope so. It's a shop, right? They're trying to do good. The profit made by the shop in year N is pounds PN. So I'm just going to zoom in so you can see this more clearly. So year N, that's how much they make. Given that the profit made by the shop in the next year is pounds PN plus 1, that's just saying that that's the money. That this small number here is called the subscript. The subscript is kind of like tells us which part of a thing it is, right? So this is in year N, so that's the profit in year N. This is the profit in year N plus 1, which is the next year. That makes sense, right? So the profit next year is equal to A times the profit of the current year plus 800, where A is a constant. The table shows profit made by shop in 2018 and 2019. Work out the profit predicted to be made in 2021. First things first, looking at this, we don't know what A is, and it seems like we kind of have to find A. How do we do it? We plug in some values, right? So I know that this would be the next year and this would be the previous year. So we'll just say let N equal, if N equals 2018, N plus 1 is 2019. So the profit made in 2019 is equal to A times the profit made in 2018 plus 800. All right. I know what those profits are, right? They're given to me right there. So I'm just going to plug those in. 29,600 equals A times 24,000. And excuse the obnoxious way of writing that, let's put a times in there. Plus 800. All I have to do is solve this equation. Quite nice so far. So if I subtract 800 from both sides, and I would get 28800 is equal to 24,008. And I just divide through. So A is 1.2, bam, first thing done. So that means I'm just going to rewrite the formula. Pn plus 1 equals 1.2 Pn plus 800. So I know that in 2019 they made that much. Let's figure out 2020, then 2021, yeah? So in 2020, the profit of 2020 is equal to 1.2 times by the profit in the previous year, right? This is the next year. This is 1 year previous. That is 29,600 plus 800. And that is going to be equal to 36,320. All right. What do I want? I want the profit in 2021. I got to go one more year. 2021. So P 2021 is 1.2 times by the profit in the previous year. So I'm using the previous number now, plus 800. And what I can do is literally just put this new number in the same formula. So that is going to be equal to 44,384 pounds. And that is my answer. So how does this look? Hopefully my explanation made the little notation a bit clearer, because I know that one thing that the notation can throw people off a little bit. Let me just check the comments if there's anything. Nothing. All right, cool. So this is how you would do this type of question. This is a recurrence relation question. Yeah, you've got one thing related to another and you're just doing the same thing each time to the previous numbers and moving on. So yeah, that's how you do this question. Again, I'll stay on this for a few seconds before I move on. And we've got a few more questions left to go. I hope this is helping you guys so far. Similar question we had to our paper too. Oh yeah, I think I heard it. Yeah, this was in that. So yeah, hopefully you guys did something similar then and you understood it well. Awesome. It could come up in paper 3, but it's very unlikely to if they've already done it in paper 2, but you never know. It could just be the most obnoxious thing or a nice thing, you know? Because remember we saw that balance question earlier? That was kind of error intervals, right? In the paper 2 of this exam, I think there was just a straightforward error interval question. So they can always assess the same thing in different ways. You never know. But yeah, hopefully you guys are similar in your paper too, guys, and this makes sense. Awesome. Let's move on. That is my solutions, my prep for this live. Okay. Ray has 9 cards numbered 1 to 9. So this is actually the paper I sat when I did my GCSEs. And I didn't like this question because it was kind of weird. It was left field question. So Ray has these cards. He takes at random 3 of them. He works out the sum. All right. I think I forgot what the word sum meant in the exam. Sum means you add the number. So just put a plus there if it helps. He works out the sum of the 3 cards and records the result. What is the probability that the result is an even number? So if I'm picking 3 cards and I want to make an even, I just got to think, what are the different ways I can select those cards? So card, I can have my first card, my second card, and my third card. I want to make an even, right? So let's say all 3 cards I picked were even. That's going to be even, right? So even plus even plus even. So these all have to equal evens, right? So if I add 3 even numbers, it's going to be even, right? Now let's throw in some odds. If I add 2 evens and an odd, do I get an even? I don't, right? Because I've got that odd has like an extra 1 to it, right? So that's going to be odd. So I can't have just an O. I've got to have 2 O's, right? So I can E plus O plus O. But remember, I can select these in different orders. That's the thing with probabilities. You've got different ways of selecting your cards. So I can have E plus O, or I could bring the E here. So it would be O plus E plus O, or I could bring the E to the end. O plus E. I sound like I'm saying nonsense, man, honestly. So yeah, these are all going to be even. So now I just got to figure out what is the probability of each of these and add them, right? So if I have even, then even, then even. If I'm doing this, I'm multiplying them across. What did you get in GCSE? I got a 9 in GCSE maths in all my GCSEs. So yeah, do we get this so far? Hopefully, like the different ways of doing this. This is one of the questions. I'll be honest. I think this is one of the questions I didn't get because I don't remember doing this. But don't worry, I've prepped for this. It makes sense to me now. So yeah, we're adding them, right? These are the different ways of adding them. So we get the even total. So even plus even plus even. How do I get that? Well, how many cards of these are even? Well, even, let's say 2, 4, 6, 8. There's 4 of those. Odd, how many odd cards are there? Well, there's 9 cards, so there'd be 5 odds. So I have one even selected first, right? So that would be 4 out of 9s. Then I'm selecting another even. Well, I have one less card to select from, so that's going to be out of 8. And I've got one less even, right? So that's 3 8s. So then it would be 2 7s, right? Because you're reducing the number of total cards you have, and then you're also reducing the number of even cards you have. So that is one way of selecting them. Or means add. So if you have and, that means multiply. If you have or, that means add. Okay, so E and E and E, you multiply. Or this, so I'm adding that now, right? So E, what is that? That's 4 9s. That's still the same, right? Times odd. How many odds do I have? 5. So there's still going to be 5 odds, but I've got 8 cards to choose from. And then another odd, well, I've got 7 cards to choose from, and I have one less odd to select from, 4. All right, plus, now what do I notice about this and this that could speed things up? Well, they're the same thing, just rearranged, right? So it's going to be identical to this above, right? So instead of adding it 2 more times and doing a whole bunch of writing, wasting time in the exam, find like simple shortcuts that make sense, right? So just proof check. Yeah, that's going to be 4 9s. That's going to be, that's going to be 5 9s. That's going to be 4 8s. That's going to be 4 7s. That's the same thing as here. So I'm just going to put them together, right? So how many of those do I have? 3. So you just add 3 lots of that. So if I do 4 9s times 3 8s times 2 7s plus 3 lots of all of that, in my calculator, I get, let me just quickly do 4 9s times 3 8s times 2 over 7. I get 19 over 42 plus 3 lots of 4 9s times 5 8s times 4 7s, 107 over 126. If I put that into my calculator, I get the total answer of 11 over 21, which is not a bad fraction to get after this mess I have drawn on the screen. But yeah, That is the probability that Ray selects 3 numbers that sum to make an even answer. Does this question kind of make sense now? Let me just move to the side. There we go. So yeah, make sure you read the question carefully. That's my advice from this question. Read the question carefully. There, he's finding the sum of these 3 cards. So you're going to add them. If you were finding the product, you'd be multiplying. Then you'd have to think, okay, what numbers multiplied by numbers make even, right? So even times even times even. Well, that's going to be even. But even times odd, well, that's also going to be even, right? Because imagine you're doing 2 times anything, right? Just think the number 2. If you have evens and odds, 2 means even. Anything multiplied by 2 is going to be even. Use that to help your logic, yeah? And this is the second last question, so you got to use a bit of logical thinking, which is not necessarily taught, but yeah, that is how you do this question. Does anyone have any questions about this question 21? Or am I good to move on to the last question of this exam? I hope this is helping you guys so far. Hopefully is calming a bit of the nerves. It's not too bad. I think GCSEs, you're almost done. Last math paper. All right, I'm going to move on to the last question. Last question is beautiful for this paper. And it's beautiful, why? Because I like algebra. Again, big nerd. So, L is a straight line with this equation. C is a graph with this equation. Using algebra, find the coordinates of the points of intersection of L and C. Whenever you're reading an exam question, underline anything important, right? So here I just underline straight line, graph, and coordinates of the points. The important thing there is they're saying the word points, right? That means you've got 2 coordinates. You're trying to find 2 points, you're trying to find coordinates of, right? Of the intersection of L and C. And also we know that we're going to get 2 sets of solutions. Why? Because we've got a linear equation and we've got some sort of quadratic. So like some quadratic. It's kind of weird because you got a y squared, right? So that means we're going to have 2 solutions. All right, this just looks like you're going to have to do a lot of work. And it's the last question. Oh, and also in the bottom right corner, it gives you your coordinates. So let's get right into it. So the way you do these is you have to use substitution. That means you take one equation, you put it into the other. So you put your linear into the other, kind of like putting a piece into a puzzle. So y equals 2x minus 5. I'm going to put that where I have y squared. So just replace that. So 2x minus 5 squared is equal to 6x squared minus 25x minus 8. All right, just got to expand out now. Done that quite a bit in this exam paper, so you should be quite fast at this now. Minus 20x plus 25. Do let me know if you want me to go over anything. I'm going kind of fast with the expansion. 6x squared minus 25x minus 8. All right, now I'm going to rearrange, bring everything onto one side and make it equal to 0, right? So I can solve an equation, right? So bringing everything onto the right side, subtracting 4x squared, I get, oh, that's ugly. Oh, one sec. The PDF doc loves to mess about sometimes with me. So I get 2x squared, bring that over, add 20x minus 5x, and then I'd have minus 8 minus 25 minus 33, and that's going to be equal to 0. Like I just brought the 0 from there to there. Like just swap the sides, yeah? Now I can solve this, right? Doesn't look too nice to factorize, and to be honest, completing the square is kind of long. Just put it into the quadratic formula. Like that's foolproof every time. So x equals, and I'm just going to write it out just for the sake, so in case someone forgot, minus b plus minus square root of b squared minus 4ac all over 2a. Now just plug in your values and remember to be careful of negatives. So for reference here, a is 2. B is going to be negative 5. Remember the negative signs. And C is going to be negative 33. All right, plug them in. So B is going to be, minus B is going to be 5 plus minus square root of minus 5 squared minus 4 times 2 times negative 33. Remember your negative signs. All over 2 times 2, which is just 4. And if I put that into my calculator, I did this before, so I'm just going to say what the answers are. You get x is going to be equal to 5.5 and minus 3. That's not it yet. Remember, they want the coordinates. So I need to find x and their matching y's. So find y values. So I know that at x equals 5.5, y is going to be equal to what? I can pick which equation up here I use. I'm obviously going to go for the first one, right? Because it's much easier to sub into. So y is 2 lots of 5.5 minus 5. That's going to be equal to 6. So yeah, this is my first set of coordinates, 5.5 and 6. And now I've got another x value, right? Another coordinate. So at x equals -3, y is equal to 2 times -3 minus 5. 2 times -3 is -6, minus 5 is -11. All right, so that is going to be my second set of coordinates, -3, -11. So far, my answers are going to be 5.5 and 6 and -3, sorry, -3, -11. And that brings us to the end of 2022 paper 3 and the end of this question. Does this question make sense, guys? Thank you for joining, whoever's here. How is this looking so far? Does this question make sense? All right. So I kind of finished faster than I thought. Is there any topics that anyone in the chat wants me to try and find questions on and do, or should I just look for another past paper and do some questions from there for the next like half hour or so? Does anyone have any suggestions or? Vectors equating coefficients. Is that kind of like equating coefficients? The question we did earlier on vectors? Like this? Or is it the weird geometric vectors problems? The one with mu and those the weird shape problems. All right, let me see if I can find one. Give me 1 second. If I'm new to using lives, so I don't know how to stop the screen. So I'm just gonna like flip the camera a bit up and look for exam questions. There's my beautiful desk, guys, and I'm on a box. So I need to find mu and lambda geometric questions. So at Excel, GCSE maths, vectors, geometry questions. Alright, PMT. Let's see. Um, just trying to remember, is this higher? So I did the higher paper, Lydia. I did the higher GCSE paper. I'm looking at the lambda and mu. I think those are more like A-level questions. I don't think they use lambda and mu for GCSE yet. No worries, Lydia. So I'm looking at these, and I don't see one where I think that might be an A-level topic where you equate coefficients. So could do that, or most likely I'll do that tomorrow. How to get grade 5 higher on Wednesday. So to get grade 5, okay, so let's do exam advice and some exam practice. All right. So Alba Lewis, is there questions? I'll check on first class maths right after. First class maths vectors. So to get grade 5s, would you end up doing a foundation paper or no? I hadn't planned, but I can do in about like 10, 15 minutes if you want, Lydia. I can do some questions from that, maybe towards the end questions, the harder questions from that, if you'd like. So my advice on getting grade 5s and above, like higher grades on maths, are underline exam questions. Underline as much as you can from the question so you fully understand it, all right? Sounds good, Lydia. See you in 10 minutes. So what you got to do is make sure you understand the question. So let me just look at a question here. long question here. So you see, I've underlined different parts that I thought were important, right? Just so I can kind of imagine I am in the question, all right? Immerse yourself into the question and fully understand what's happening. Then you need to see what topic is the question asking. So this one, we can see we're talking about percentages, right? And depreciation, right? So the topic would be percentages. Get your head in the mind frame of percentages then, yeah? So think, what do I know about percentages? How can I apply that here? And just do it like that. Another bit of advice would be don't waste time on a question. And I'm a bit of a hypocrite for saying that because when I did some of my question papers, I would spend too much time on one question just making sure I got it, that I ended up not having too much time for later questions. You have to make sure you're strict with yourself. If a question is not worth that many marks or is taking way too long, stop and move on. Because this question you can see is 3 marks, kind of a bit of working, is not too bad. But then if you go down, you can see some other questions like this is also 3 marks. It's less working, right? So it wouldn't take as long. Just see the number of marks, see how much time you should allocate, all right? Don't waste time in the exam. Okay. What else can I say? Yeah, look at the number of marks. Speaking of marks, look at how many marks each question is worth. If a question like is worth 2 marks, you need to make sure, have I done 2 marks worth of working? Because if you've just done one line and you know you've like not done a shortcut, think, is there something else missing? Then do that. For example, this question up here, question 14a, notice is 2 marks where you're factorizing. The first mark comes from taking out the 4, but the second mark you need to notice is a difference of 2 squares. That's another thing you could also look out for, difference of 2 squares. They would be hidden. I've rarely seen obvious difference of 2 squares questions, unless it's just like an algebraic thing here. Um, you've done your exams, papers 1 and 2. Hopefully, you guys like remember or have made a note of the topics and types of questions that have already come up. They're kind of unlikely to come up again, but they can still. So you know like where to prioritize your revision. So for example, if a vectors question hadn't come up in paper 1 or 2, you can count on it that a vectors question will appear in paper 3, most likely. So just prioritize your revision. Make sure you're trying to understand the math. That's the thing that's not said by too many people, but is really, really important. So when I was initially revising for my GCSEs, I'd kind of like just memorize stuff and be like, okay, I'd look out for this if something's like this, just memorizing the rules. But try and understand the patterns. Try and see why things are like what. Okay? Because if you actually understand the math, then you'd be able to, spot the tricks that some people tend to miss. Yeah? So to get grade 5 and above, prioritize your time, check the number of marks for the questions to make sure you've done sufficient working and that you don't waste time on those questions. Do questions you like. It'll help you, yeah? When you open that exam paper, flick through it real quick, all right? In the first 30 seconds, look through, get a gauge to see what you're going to expect. And if there are any questions that you like, do those straight away. Yeah, it'll kind of help ease you into the exam, put you in a better mood, and you won't be, flustered and put off. Yeah. So those are my tips for getting grade 5 and above in the exam. And if you're wanting to aim for those top grades like 7s, 8s, and 9s, fully understanding the concepts, questioning it. Yeah, like speak to your maths teachers. You're like they're still there at school, right? Go to them before the exams, ask them questions, like really delve into the topics. Watch videos. I've got plenty of videos currently. I think I got like 42 videos on my channel so far, and I'm still adding more. Tomorrow I'm gonna post some more GCSE videos. I think I'm planning on posting hopefully 3 GCSE videos, and I'm doing another live again tomorrow where we'll do some more questions. But yeah, watch videos, do readings, really try and understand, what's happening and you should hopefully be able to get those higher marks. So for the next half an hour, I think I will go through a GCSE foundation paper. So let me just pull that up. Can we do this whole paper from question 1? What I'm going to do is I'm going to this live is recorded, right, Alba Lewis? So I'm have a YouTube channel with the same name, a user. I'm going to post this live to my YouTube channel later, just after 8 o'clock or so, once I've finished, and you can watch the video there. So, is there any question in particular you wanted to check from this paper, or does that sound good? Awesome. So I'm just looking for a foundation paper right now. All right, so we're gonna do this GCSE foundation paper. I just did the higher, so if you want to see that, that's on my I'll post that to my YouTube channel after the live. All right, cool. All right, welcome. So we are going to do the 2023 GCSE Maths Foundation paper. Let me just check I've got the correct one. All right, cool. So let's get started. Welcome, guys. We are going to be doing the foundation paper 2023 November. And this is in preparation for the maths exam on Wednesday coming up, GCSE Maths. So I'm gonna, let's just jump right into it. So write 35% as a decimal. So whenever you're writing a number as a decimal, you need to, wow, this is a thick pen, hold on. If you're writing as a decimal, you need to think that 1.00 equals 100%, yeah? So this is what you do, 100% equals 1. So how am I going from here to here? I am dividing by 100, all right? So whenever you convert a percentage to a decimal, divide by 100. So 35 divided by 100 equals 0.35. And that's how you would do question 1. So question 2, write 8,061 to the nearest 100. So, hey Lydia, so I just started the paper. I just did question 1 so far. So write 8,061 to the nearest 100. So I need to round to the hundreds. So I'm going to look at the hundreds column. This is my tens. This is my ones, tens, hundreds here. So now I look to the column to the right of that. And I need to see, do I round up or down? So here it's a 6. So 6 is bigger than 5. So that means I'm going to round up. So this 0 is going to increase to a 1. And then the other numbers, so this would be 100, right? And then I'd replace those numbers by a 0. So this is the answer to question 2, 8,100. All right? Write down a number that is less than -5. So remember, if we're doing negative numbers, if you have, like, just think about it. If you're in debt, like, hopefully you guys don't get in debt, but if you're in debt and you have -100, that's a lot worse than -5, right? Like, think about it that way. So if you've got a number line, you'd have 0 here, and then you'd have 5 and 100, right? So you can tell that -100 is less than -5. So this is one number. It could be literally any number. You can put like decimals, fractions, as long as it's negative, and as long as the number itself is like a bigger number than 5 in terms of size. So yeah. Here is a grid of squares. What fraction of the grid is shaded? With these, just count, all right? So how many squares do I have in total? That will be my denominator, right? Because it's like a test score. This is going to be your total, and this is going to be how much you have. So this is half. All right. So how much is there in total? I've got 1, 2, 3, 4, 5, 6, 7. And I've got 3 rows of that. So 7 times 3, 21. That's going to be my total, right? How many is shaded? 1, 2, 3, 4, 5, 6. 6. Can I simplify that? I can. So I can. It doesn't say I need to, though. So the answer could be 6 out of 21. But if I did have to simplify it, how would I do that? Well, I'd see what number goes into both 6 and 21. 3, right? So 6 divided by 3 is 2. 21 divided by 3 is 7. So I could also put 2 sevens. Either of these will get you the mark. If it doesn't say simplify, maybe don't risk it. Just give the number as is. All right. Question 5. Write down the value of the 9 in the number 27.963. So this is about place values, all right? So we know that the 7s is the 1s and that's the 10s. And now we're going after the decimal place. So remember, we don't have a once. That's a weird word, so it doesn't exist. So we have tenths straight away. Tenths, all right? So that's what you'd say. The 9 is the tenths column, right? The next one would be hundredths, the 6, and the next one would be thousandths. I'm trying to like emphasize the th. It's like after the decimal, you put a th, and you forget there's no once. Once is a weird word. Forget that. It doesn't exist. All right, so the 9 would be tenths. You could also put 9 out of 10 because that's 9 tenths. Yep. Well, that's page 1 done. Question 6. The pictogram shows information about the number of chocolate cakes, vanilla cakes, and lemon cakes sold by year 7 at a school fair. So chocolate, vanilla, lemon, banana. This whole circle with 4 slices represents 12 cakes. 24 banana cakes were sold by year 7. use this information to complete the pictogram. So if one whole circle, so four parts is equal to 12 cakes, right? We're happy with that? So I've got 24 cakes. So how many parts is that going to be? Well, I'm trying to go from 12 to 24. I'm just doubling that, right? Multiplying by 2. So from 4, I'm just going to multiply that by 2. So that means that's 8 parts, right? Each of these is a part here. So that means I've got one whole circle with 4 parts and another whole circle with 4 parts. And that's how I would do part A, all right? Part A. I'm not funny. At the fair, year 8, so this is a different year group. Notice this is year 7, this is year 8. They sold a total of 150 cakes. Which year sold the most cakes at the fair? Year 7 or year 8? And you gotta show how you get your answers. So while we already know that year 8 is 150, we have to figure out how many year 7 sold, yeah? How many year 7 sold? How am I gonna do that? Well, I know that they sold all of these cakes. So the whole circle is equal to 12. So I'll first count how many whole circles I have and put the number there. So I've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got, oh shoot, oh don't tell me it all rubbed out. Oh great. So I've got 11 lots of this, which is 12, yeah? Just quickly put that there. All right, yeah. PDF loves rubbing out on me. So I've got 11 lots of 12, right? So there, bum, 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 bum. So 11 times 12, I can put that into my calculator, and I get 132. All right? Now, I've got these fractions, okay? So this is a quarter of that, right? That's one part. There's 4 parts here. So 4 parts, remember I'm going to do the same thing. 4 parts equals 12. Here I've got 1 part, right? 1 part equals 4 to 1 is dividing by 4. So 12 divided by 4 is 3. So that is going to be 3 cakes. So I've got 132 plus 3. And this bit, well, that's 2 parts. So from 4 parts to 2 parts, I'm dividing by 2, right? So 12 divided by 2 is 6. So plus 6. And if I add those, I get 132 plus 9. And 132 plus 9 is going to be equal to 141. So that is how many cakes year 7 sold. Have I answered the question yet? No. I just need to say which year sold the most cakes. Well, year 8 sold 150 cakes. So, well, year 8 sold more. Yeah, why? Because 150 is greater than 141. Alright, so that's how you would do this pictogram question. So, question 7. Miklos is, let me just, sorry, quickly check how many questions there are on this. 29. So I'm going to skip some questions just so we can move on to the harder questions. So this one looks like a question worth doing. Question 7 looks a bit weird. So, one second, let's get rid of the side panel. All right, cool. So Miklos is swimming lengths of a swimming pool. Each length of the pool is 25 meters. Miklos has swum 178 lengths of the pool. That is insane. He wants to swim a total distance of 8,050, so he wants that. Calculate how many more lengths he needs to swim. Okay, now for this question, I want you to imagine you are this Miklos guy who is probably on steroids swimming 8,050 meters in that pool, which is insane. So he has swum 178 lengths, and each length is 25 meters, right? So how many meters has he swum? Well, he swum 178 times 25, and that is equal to 4,450 meters. So far, he swam. He wants 8,050, right? So just think, how many more do you have to go? Well, that's just a subtraction. 8,050 minus 4,450 equals 8,050 minus 4,450, 3,600 meters. Yeah? That's how many meters he has left. Do not put that as your answer, okay? Because the question says how many more lengths, okay? This is why underlining and circling is so important. So if he has this many meters left, one length is 25 meters. So to figure out how many lengths, you do 3,600, so lengths is 3,600 divided by 25. Put that in my calculator, I get 144 lengths left. And that is how you do that question. So for this one, the trick is, remember to divide at the end to find the number of lengths, not the number of meters, all right? So that's how you do it. Question 8, I'm not going to write, I'm going to speak through this one. Here are the first 4 terms of numbers in a sequence. All right, cool. Those are numbers. Nice. Explain how to work out the next number of the sequence. Well, let's see what I'm doing to go from each number to each. 97 to 91. If I don't know what I'm doing, I can just put in my calculator. 97 minus 91. Oh, that's 6. So I'm subtracting 6. Let's check. Am I doing the same thing here? 91 minus 6 is 85. Yep. 85 minus 6, 79. All right, cool. So how do I work out the next number? It's just telling me how. It's not telling me to work it out, right? So I would just do subtract 6 from each number, yeah? That's it, 1 mark. Work out the difference between the 5th term and the 7th term. Well, I've got 2 terms, right? So what would my 5th, I don't even need to figure out what my 5th and 7th term are, but I could, just to make it easier, right? So if I'm subtracting 6 from 79, I get 73, and subtract 6 again from that, I have 61, and then I subtract 6 again, sorry, that's the middle one, skip the step. Then I have 73 minus 6, I have 67, then I have 61. So this is 5th, 6th, and 7th terms. I'm going to see what's the difference between this to this. Well, that's just subtracting 12, right? Because I'm subtracting 6 twice. There you go. Explain why 52 is not a number in this sequence. Well, look at the sequence. Now we got to think, why is 52 sticking out of this sequence? 52, for starters, is an even number. But if I look at all of these numbers, they're all odd, right? So I just say 52 is even. The sequence is all odd. If I didn't notice that, I could also just find the next few numbers, right? So if I subtract 6, oh my god, it disappeared. 73, then I have 67, 61. So 52 is even. Then if I subtract 6 again, I have 55, and then again 49. Well, 52 is somewhere there, right? So it doesn't exist. So I could just say that it goes to 55, then 49. So you don't reach 52, which is why it's not in the sequence. Either one of those reasons is fine. How's this? Hopefully this is making sense so far. All right. Longer question again, so let's do this. Mandy buys 12 kilogram bag of dog food. Mandy's dog has 3 meals a day. I'd hope so. She gives her dog 105 grams of dog food for each of these meals. How many complete weeks will the bag of dog food last? You must show all your working. This is 5 marks. It's quite a longer question, as you can tell. Why? Well, I'm going to underline now. 12 kilograms, 105 grams, 3 meals a day. How many weeks? Okay? So, if they have 3 meals a day, let's just figure out how many grams in a day. Grams in 1 day, yeah? That's just 105 times by 3, which is 315 grams in 1 day. I'm going to convert that into kilograms, right? Because the bag has 12 kilograms. Or, let's make it easier, let's convert 12 kilograms to grams. If you forget how to convert metrics, just do this on the side. And I used to not be so good at metrics as well when I was doing GCSEs. But I knew that 1 kilogram is equal to 1,000 grams. So I have 12 kilograms, right? How am I getting from 1 to 1,000? What am I doing? Multiplying it by 1,000. So to get from 12 kilograms to grams, I'm also going to just multiply by 1,000. So that's equal to 12,000 grams. All right, you see how we did the conversion? So that is how many grams is in the bag. So in the bag, I have 12,000 grams. In a day, she feeds the dog 315 grams. So let's see how many days the food lasts. So I've got 12,000 and I have 315 a day. So if I do that, 12,000 divided by 315, that lasts me about 38.09 blah 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 days. All right. I need how many complete weeks? Well, it's telling me complete weeks, right? So whole weeks. So I've got 39 days. I'm going to divide that by 7, right? Because there are 7 days in 1 week. Again, you can do the conversion thing here, right? So days to week, what am I doing? Divide by 7. So 38.09, blah, 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 divided by 7. That's going to be equal to 5.44, blah, blah, blah. So the whole number of weeks is 5 whole, right? And then I've got 0.44 blah 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 of a week. But the question didn't ask me how many weeks exactly, it tells me how many complete weeks. So complete weeks is just 5 whole weeks. And that's how you do this question. So a bit of a longer question, but if you just work it through, imagine you are Mandy and you're feeding your dog that much a day. You got a plan for this dog, right? This is how you do this type of question. All right. So immerse yourself. It kind of makes maths a bit more fun if you are pretending you are this Mandy person. Well, not always, but yeah. Here is a polygon. Write down the mathematical name of it. Well, let's count the sides. 1, 2, 3, 4, 5. 5 sides. And what does it look like? It looks like a house, right? Penthouse. So this would just be a pentagon. Because it looks like a penthouse, like a house. All right. Here is a prism. Each edge of the prism has a length of 7.5 centimeters. Work out the total length of the edges of the prism. All right. So each length is 7.5. I just gotta see how many lengths have I got. Well, I know this has 5 sides. 1, 2, 3, 4, 5. So I've got 5 sides there. The back also has 5 sides, right? Because it's the same shape, right? Plus 5. How many sides are there on the outside? Well, I'm joining it there, so that's 1. Joining it there, 2, 3, 4, 5. I'm joining it on all 5 sides, which makes sense, right? Each of the front faces joins to each of the back faces. So 5. I've got 15 side lengths, side lengths. So the total length is just going to be 15 times how much is one length? 7.5, and that is 112.5 centimeters. And that's how you do this question. So not a bad question. Like, just remember to count the number of sides and understand each question in depth. All right. Question 11, ratios question. Ratios tends to throw quite a few people off, but let's just follow it through one bit at a time and try and understand what we're actually doing, yeah? There are only red counters, blue counters, and green counters in a bag. The number of red to blue to green is this, okay? What fraction of the bag are green counters? So I need to convert this to a fraction, right? So remember, with a fraction, the top number and the bottom number, the bottom is the total, and the top is half. That's how much I have in relation to the question, okay? So I need to find how many counters in the bag are green. Well, this is red to blue to green. Just write that above, yeah? How many are green? I've got 7. So that's 7 out of how many are there? I have got 2 reds. I've got 16 blues and I've got 7 greens. So that means the total is 2 plus 16 plus 7. And that is going to be equal to 7 over 25. That is how you do that. Remember, with this, to find the total, you add all those numbers. And this is for a fraction because it's scale, like ratios. Remember, you can always scale a ratio. So this is how you do it. Like imagine it's all been simplified here. And they don't ask you how many greens are there. Well, it tells you the number of green is that. But yeah, it's not telling you the ratio of it. It's giving you the numbers as a ratio. So there's a little difference there. Don't let it throw you off. So hopefully this makes sense so far. All right, cool. Let's move on. A chess match lasted 3¼ hours. That is a long chess match. All right. The match finished at 14:10. I think they're meant to be 2 dots there. At what time did the chess match start? Well, I've got 3¼ hours. I know 3 hours is just 3 hours, right? How much is a quarter of an hour, right? So a quarter, let's convert that into minutes, right? So a quarter of how many minutes are there in 1 hour? 60 minutes, right? Equals 1 hour. So a quarter of that is going to be equal to 15 minutes. So this, in other words, means a chess match lasted 3 hours and 15 minutes, right? Now this is just a nice time scheduling problem, right? So if it finished at 14:10, It started 3 hours and 15 minutes earlier. So 14 minus 3 is, I started at 11:10, but I'm also starting 15 minutes earlier, right? So 15 minutes before. So if I do 10 minutes, that's 11 o'clock, and 5 more minutes, that's 10:55. So that is when this chess match started. That is crazy. Imagine being in a chess match for that long. I mean, I like chess and all, but that is just such a long time. Okay, cool. I waffled too much. Simplify this. Okay, let's see what I'm gonna do. These are all like terms. Do not be thrown off by the fact that there is an h cubed. Notice all of these have that buddy. It's like their buddy. They're holding on to that h cubed. So I've got 8 lots of h cubed, and I've got 14 more lots of h cubed. What is 8 plus 14? If I put that into my calculator, I get 22, right? So this is 22h cubed, and I'm subtracting 2h cubed. All right? So now I've got 22 lots of this thing, and I'm taking away 2 lots of it, right? So that's just going to be 20 lots of h cubed. And that's it. Just like that. 20h cubed, all right? Always think of it like it's holding on to its buddy. It's got that many lots of something, all right? Simplify 9y plus 12y divided by 3. Okay, this is a bit of a weird one, but remember, it's holding on to their buddies. So we know that 9y plus 12y is 21y divided by 3. Now I need to figure out what this is, right? So how many times does 3 go into 21y? Well, 3 doesn't really go into the y, so that just stays as is. How many times does 3 go into 21? 7, right? So that's 7y, and the y just stays there. So this would be 7y. Because remember, it's like writing 21y over 3. 21 divided by 3 is 7. The y doesn't have any y's to divide by. It just stays like that. And that's it. Nice little algebra question there. 14. Write the following numbers in order of size. Start with the smallest number. Should I go through this question, or should I skip this question and go into some harder questions? I think what I'll do now is I'll go from backwards because I'll be logging off in a few minutes. So I'll go to the end of this paper and we'll work backwards. How does that sound? If anyone in the chat wants to let me know. All right, let's do the hard questions because that's what's worth our practice. All right. So, question 29. Let me just scroll down. All right, cool. A, B, C, and D are points on a circle such that A, B, C, and D is a square. It's important to note it's a square, so underline that, yeah? All the sides are the same. The square ABCD has side lengths of 3.5. So I'm just going to put that this is 3.5, and these are all 3.5. They're all the same. So just put the line there, yeah? Just shows all the same. Yes, awesome. Let's do the questions from the back. So, calculate the circumference of the circle. Give your answer to one decimal place. You must show all your working. So how am I going to find the circumference? Well, let's just state what we know, right? So circumference, just write what you know. If your mind is blanking and you don't know where to start, put what you know. How do I find the circumference? Pi r squared sounds like area to me. If I need the circumference, I just use pi d, or 2 pi r. All right, either one of these formulas works. So I need to find what 2 pi r is, right? So let's find what the diameter of this is, yeah? So if I know that that's 3.5 and that's 3.5, the diameter goes from one end to the other end. But I've got side lengths missing there, right? However, this to this goes across. If you look there, this is also a diameter. And I've now just got a little triangle there. So if I just redraw my triangle here, with this being 3.5 and this being 3.5, I can easily figure out what this diameter is. Let's call the diameter d. Makes sense, right? D for diameter. So, using Pythagoras, it tells me that a squared plus b squared equals c squared. C squared is important. That's the longest one, right? Because something plus something equals something that's big. So this is going to be c. So 3.5 squared plus 3.5 squared equals d squared. So if I add these, I get 3.5 squared plus 3.5 squared, 49 over 2 equals d squared. How do I figure out what d is? Square root both sides, right? Because if I'm squaring it here, the inverse of that is square root. So D equals square root of 49 over 2, square of 49 over 2. And that gives me 7 root 2 over 2 in my calculator. So I'm just going to leave it as that for now. I'm not going to round or get a decimal yet. So now I know what D is. The circumference, I can just use this equation, right? So therefore, circumference equals pi D, which is 7 root 2 over 2 times pi. So if I multiply that by pi, I get 15.55 blah, blah, blah. I want this to one decimal place. When you see this, and it tells you around, just write it in big on your exam paper somewhere, so you know that that's what you have to do, right? So 15.555, I'm going to round to one decimal place. How do I do that? Well, I look, this is where I want to round to. Look at the number after it. That's a 5. That means I'm going to round up. So this is going to be 15.6. And this is how you do this last question. Does that make sense? So it's about trying to look at it from a different angle. Start with what you know. You know the formula of a circumference is pi d. So we need to find the diameter. I'm looking at my shape. I look, oh, that's the diameter. It's a diagonal bit, but it's still the diameter, right? From one into another. I can do some Pythagoras and figure it out and sub it back in. So yeah, that is how you do that question. Question 28. The line L is shown on the grid. Find an equation for L. So again, start with what you know, right? What is the equation of a straight line? Y equals mx plus c. You need to find two things, m and c, right? Because y and x are kind of like, they're your variables. They're just there. They're going to always be there, yeah? So m and c are what we want to find. What is m? M is the gradient, right? So we need to find the gradient. So m is equal, like, let's pick 2 points here. Let's pick this point, because that's like on the line, right? And another point here is on the line, all right? So the gradient is the first y value, so it's the change in y divided by the change in x. So y goes from 3 to -1, so minus 1, right? Because remember, two minuses make a plus, so that's like 4. Because you can see the total height difference is 4. From x here to here is 2, so you know it's just 2, right? But what you need to notice is it's negative, right? So here you're doing 0 subtract 2, so it'll be -2. So that is your gradient, yeah? It's going backwards, so you know your gradient is going to be negative, yeah? We found m. Cool, let's find c. What is c? Well, c is just the intercept. Here it intercepts at 3, so that is just my c value, right? Awesome. Now we just sub in. So y equals -2x plus 3. That is how you find the equation of a straight line. Just know your equation, see what you need to find, m and c, find the gradient, find the y-intercept, and there you go. Remember, if it looks like it's going down a slide, it's a negative gradient. If it's like this, m is going to be positive. It's going to be a positive gradient. Let's do 2 or 3 more questions, and I think we'll wrap it up there. This question looks a bit weird, so let's go for it. Question 27. The diagram shows a solid cube placed on a horizontal table. Well, I don't see a table, but there's a cube. Let's just believe the pressure exerted on the table due to the cube is 3.5 newtons per centimeter squared. If the units throw you off, ignore them kind of for now while you read the question. The force exerted, so that's the pressure, that's the force. I put above here P. The force exerted is 504 newtons. That's F. It kind of helps to put the letters by the numbers. Show that the total surface area of the cube is less than 900 centimeters squared. Now, what you need to notice is that they say total surface area. So this formula, pressure is force over area, that just gives you the area of the base, right? Because imagine here's your table. I'm going to draw it out for you because they're evil and they didn't. That kind of is off-putting. So they're blah, 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 blah. Yeah, see, this is the area that they're talking about because it's sitting on the table, like you've got a box on the table, but they need the total surface area. So we'll get to that in a moment. So I know that pressure equals force divided by area as given here. So area, if I rearrange, is force divided by pressure, right? I multiply by A and then I divide by P to rearrange for A. So A equals force, which is what? 504. Now this is where I just look at the units. Just make sure they're all the same, right? So newtons, yep, they match. Centimeter square, yep, they match. If they didn't, then I'd have to do a bit of conversion, but they do, so we're good to move on. So force is 504 divided by the pressure, which is 3.5, and that tells me that the area is 144 centimeters squared, right? Because that's what the units of area are. But wait, that is the area on the bottom. That's what is touching, okay? So I need to see what is the total area of this cube. So total area is 144 multiplied by how many sides does this have? It's a cube, so it's got 6 sides. That's going to be equal to 864 centimeters squared. Well, is it less than 900? Nice, it is. So I could just say less than 900 centimeters squared. So then I could just say the total surface area is 864 cm squared, which is less than 900 centimeters squared. And cool, I proved the point, like I proved it correctly. Nice. So it is evil, but it's towards the end. Just notice for trick questions. As you can see, it's super important. Underline. All right. If one thing you could take away from this live is, well, hopefully you've taken away a lot of things, is underline the questions, okay? It is so important to read the questions carefully because some people would just say 144. Oh, well, 144 is way less than 900, so it's obviously true. But wait, you need to multiply by 6 because why? It's the total surface area, all right? So that's how you do that question. All right, few more questions. Riley traveled by car and by airplane. He traveled 143 miles by car at an average speed of 55 miles per hour, then traveled for 5 hours and 20 minutes by airplane. Work out in hours and minutes his total traveling time. All right, so I'm told that he traveled 143 miles at a speed of 55 miles per hour. Well, I'm being told the distance here and I'm being told the speed here. What do I want? I need a time, right? What equation links speed, distance, and time? Speed is distance divided by time, right? Because speed is how fast you're moving, and you're moving a certain distance in a certain time. So yeah, distance per time is speed. That's how you do that. So I need to find the time, right? So let's rearrange. So I want to get time on its own. So let's bring it up. So I multiply through by time. So time, so I'm just going to put the letters now. T times S equals D. I want T alone, so I do the inverse of here. So I'm multiplying, inverse of that is division. So T equals D over S. So the distance they traveled is 143 at a speed of 55 miles per hour. So that is equal to 143 divided by 55. That's equal to 2.6. What's the unit? Well, hours, right? Hours. I have got to convert this into hours and minutes, right? So we know that is 2 total hours and 0.6 of 1 hour. Well, that's just going to be 0.6, 0.6 times by 60, right? Because remember, 1 hour equals 60 minutes. So to get that, 0.6 times by 60. That's equal to 36 minutes. So the first bit, they traveled 2 hours and 36 minutes. Then they traveled for 5 hours and 20 minutes. So in total, they've traveled 7 hours and how many minutes? 56 minutes. And that is the answer to this question. Just break it up, see what you have, see what you want, and go through. That's how you do that. All right, let's finish off this page and I'll wrap it up there. So Ali buys packs of balloons and boxes, packs of balloons and boxes of pencils. There are 30 balloons in each pack and there are 24 pencils in each box. All right, see, I'm underlining as I go. Ali buys exactly the same number of balloons and pencils. Work out how many packs of balloons and how many boxes of pencils he should have bought. He could have bought, sorry. You must show all your working. So, she has bought 30 balloons, like each pack has 30 balloons, right? So I'm just going to write that out. balloons, 30 in a pack. And then pencils, 24 in a box. What exactly am I trying to find here? Well, I'm trying to find common multiples, right? So I need to find the lowest common multiple of each. So one way I could do that is by doing like a factor tree, right? So let's do a factor tree. So 30, if I break that down, what two numbers could I, just any two numbers and multiply to get 30? 3 and 10, all right? That is a prime factor. What two numbers multiply to get 10? 2 and 5. Oh, cool. Well, that got rid of my 5. So that is equal to 2 times 3 times 5. 24 is equal to, let's see, what two numbers multiply to get 24? Would it be 4 balloon packs and 5 pencil packs? Exactly. That is the correct answer. Nice. So I'm just going to figure out doing the working, but yeah, that's correct, Lydia. So 4 and 6, well, this can go in 2 and 2, and this can go in 3 and 2, right? So boom, 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 boom. These are all prime factors. So this would be 2 times 2 times 2 times 3. So now, if I just do my prime factor decomposition, I would eventually get that there are 4 packs of balloons and 5 boxes of pencils. And that's how you would do that with the additional step of your Venn diagram. All right. So question 25. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? Again, write out what I have. 30 hours is equal to like 4 machines, right? Well, I need to make them in 6 hours, all right? So this means I need to make it dividing the time by 5. So if I'm trying to do it 5 times as fast, I'm going to need 5 times as many machines. So this is an indirect, like it's in, as one increases, the other decreases, right? So if I need to decrease the time, I need to increase the machine by the same proportion. So I multiply this by 5. So 4 times 5 machines, right? That's going to be equal to 20 machines. So they need 20 machines to make the same number of plays. As one increases, the other decreases. For these types of questions, just kind of logic it through. Just think, okay, if I have less time, if I need to make it faster, am I going to have more or less machines? I'm going to have more machines, right? If I'm making the same number of plates. So that means if I'm dividing the time by 5, I'm going to multiply my machine by 5. So as one decreases, the other increases. Just think how the relationships work, and that's where like a bit of common sense comes in. Yeah, I hate sometimes having to use common sense in exams, but it is what it is, all right? You know what? Let's do some more questions, all right? It's getting a bit fun. I sound so sad saying that, but I've got more people on this live, so hopefully this will help. Jenna is asked to show the inequality -3 is less than x, which is less than or equal to 4 on a number line. Here is her answer. Okay, so Jenna has made 2 mistakes. So the first thing we should know that is if you've got a less than sign or greater than sign, you use an empty circle. But if you've got that extra line, you're going to go that extra mile and you're going to color that in. Here, she has not colored in this circle. So you need to say, he has not colored in the circle at 4. All right, that's one of the mistakes she's made. All right, she's made another mistake. Let's see. -3 is less than that. Circle is good, but the number, whoa, the number is wrong. So this is what her line is meant to look like. So the line should start above -3, or she should draw the circle above -3. Yeah, she hasn't drawn it there. Be better than Jenna and draw your diagrams properly on a number line. So this is how you do it, all right? We're going to be better than Jenna in our finals. So work out the greatest integer that satisfies the inequality 5y minus 7 is less than 16. Just think of this as an equation, yeah? So if I just rewrite this, 5y minus 17 minus 7, sorry, is equal to 16. let me just solve this as an equation. So if I add 7 to both sides, I get 5y is equal to minus 7 plus 7 is 0, so that goes away. 16 plus 7 is 23. If I divide through by 5, I get y is equal to 23 over 5. Now here, I can just replace it back with this less than sign. So y is less than, let me just check, 23 over 5. Now, this is where I have to be a bit careful. What is the question asking me? The greatest integer. So what is 23.5 as a decimal? That means that y has got to be less than 4.6. Well, what's the integer that comes right before that? 4. So what is the greatest integer that satisfies this? 4. That's how you would do that. So underline, see what you have to do. When solving these, you can just replace the inequality sign if you want with an equals. But remember, I wouldn't advise doing it this way, like this is just in brackets. Use the inequality sign, because if you multiply or divide by a negative, the sign flips. If any of you have pen or paper there and are studying along with this, that is so important to make a note. If you're multiplying or dividing when solving an inequality equation, there's not equation, an inequality, the sign flips the other way, okay? That's very important. But if you add or subtract, the sign stays the same, as you can see here. So cool. Let's do another question. I know I said I'll only do a few more, but let's just keep going. Seija works at a weather station. The table gives information about the temperature T degrees Celsius at midday for each of 50 cities in the UK on Tuesday. All right, cool. Well, that's tomorrow, so I don't know how they're predicting that. Calculate an estimate for the mean temperature. So we need to find the mean. I'm not gonna lie, I kind of hated these types of questions, but let's just work on it, all right? So to find the mean, notice these temperatures are ranges. This is a continuous variable. So I need to find the midpoint. So I like to create an extra column called midpoint, all right? So what is the midpoint between 10 and 15? Well, to find the midpoint, I'll do 10 plus 15 divided by 2. It's like finding the average of it, right? So 10 plus 15 divided by 2, that's equal to 12.5. So I put 12.5. Remember to show you're working, but if there's something like repetitive like this, where you're finding the midpoints for all, maybe just put one step and then you could just do the rest yourself. So 15 to 20, the midpoint of that is 17.5. Then you'd have 22.5, 27.5, and 32.5. All right, now I have to find the total, right? So if I've got two lots of the temperature being 12.5, well, that's just going to be multiplied, right, to equal 25. So I got 8 lots of 17.5, right? Because remember, this is like an estimate. This is an average. So I just multiply all of these, and I add that to get the total temperature, right? So if I just multiply it through, which I'm going to do real quick, 140 equals 292.5 equals 577.5 and equals 195. And now if I add all this, I get 1230. So this is like my total degrees Celsius measured in the entire 50 cities on that Tuesday, right? But I need to find the mean temperature. Well, I've got 1230 degrees in 50 cities. So I just divide through, and if I put that in my calculator, 1230 divided by 50, I get 24.6 degrees Celsius as my mean. All right, so that's how you do it. If you struggle like trying to logic it through, the way I did it at GCSEs, I'm going to be completely honest, I memorized how I did it, then I slowly understood how to like logic it through. So you see this, find the midpoint, multiply the midpoint by the frequency. So this would be MF, kind of helps to remember. You find, let me just move the camera. So you've got M and you find MF, you add that and you get the total, then you just do the total divided by the number that there are. And that's all you do for this. All right, last question I'm gonna do, and then I'm gonna wrap it up for today. I'm going live again tomorrow, by the way, from 6 to 8, where I'll be doing some GCSE content from 6 to 7, and I'll be doing some A-level stuff after that. So join then if you would like to see some more exam practice question before your exam, and I wish you all best of luck. So last part, Stages says, the median temperature is 22.5 degrees Celsius because 22.5 degrees Celsius is the middle number in the middle group. Is Seja correct? So think about it. The median temperature, well, no, right? Because you don't know that a temperature is actually 22.5 degrees Celsius. That is an estimate, right? It's very important that you understand we're estimating, like we're just saying, let's just assume that the midpoint is what all those temperatures in that range were like, right? So I could have a temperature here that was 21, 22, 23, several 23s, several 24s, and a 25, and I've got 13 lots of numbers in that group, right? None of them necessarily have to be 22.5. So is Sage correct? Well, the obvious answer is no, right? So the median is in the interval. So now we have to think which section has the median. Well, we've got 50 cities, right? So this is 2 cities, that's 10 cities, that's 23 cities, 25. The 25th city would be the median. So it would be in this interval, right? Is in the interval 25 is less than t, which is less than 30, right? It is in that. So she did not take into account frequency. If I can write. So let me just say what the mark scheme says so you know what other things you could say. So no, the median is in the interval 25 is less than t, which is less than or equal to 30. No, the median is in the group containing the 25th temperature. Or no, she did not take into account frequency, which is what I tried to explain at the start. Or no, the frequencies are not the same for each group. So that is my little wrap on doing the foundation, some questions from the foundation paper. I hope that was useful for you all. I will be going live again tomorrow, so make sure to join then. It will be, I think, sorry, 6:30 to 8:30. You can check what my pin post is. The time is there. But yeah, no worries, Lydia. I hope this was helpful. Hopefully, looking forward to seeing all of you on my live tomorrow. But yeah, best of luck. Feel free to DM me if you have any questions or any suggestions, and I'd appreciate a follow. Thank you, everyone. Have a nice night.